Next set of slides, Chris from Broadcom is going to sort of use that setup to talk a bit about the LTE, LAA set of issues and role of regulation and in that space.
Thanks, Paul. So first of all, for the person that's controlling the slides, I'm sorry, these are a little bit interactive, so there's going to be multiple clicks. First of all, what I wanted to talk about was a little bit of our research regarding coexistence of new technologies. And coexistence is something that Broadcom knows quite a bit about. We've built a substantial business doing this, I think $15 billion in revenue last year. We're a global leader in wired and wireless communication semiconductors. So we build semiconductors for things that you'd have in your home, things that you'd have in your hand, the network infrastructure. And it's all about efficient movement of packets from point A to point B. If you don't have efficiency in your network, it doesn't matter how great your Wi-Fi is, how fast your backhaul is. So we care about the entire ecosystem. And we've been looking at the impact on Wi-Fi. The impact on Wi-Fi, specifically what I want to talk about today is broadband access. How you could have reduced broadband access if LTE and LAA aren't changed sufficiently before they're adopted. And so this little setup right here, you see a distribution of Wi-Fi links. And I'm going to speak in dBm. I know it's a little bit painful here, but basically that arrow in that little pink box kind of shows this is the typical Wi-Fi link. Typically about 50% of your links are either at that arrow or at a weaker signal. And what we did is we wanted to drop an LTEU and an LAA node in randomly near various places next to a Wi-Fi AP, and we wanted to see what the impact would be on your link. Now, I'm going to be using a little bit of acronym mumbo jumbo. LTEU is proprietary technology that was introduced by a handful of companies, and LAA is a standardized version of that. But what's important to understand is Wi-Fi has evolved from day one. It was an unlicensed technology and has evolved from that point. LTEU and LAA have evolved from a licensed place. So it's a very different type of technology, and it's evolving to use the unlicensed spectrum. And so there's some important considerations that we think need to be covered before it's widely adopted. Next slide, please. So first of all, we wanted to look at several different scenarios, the typical Wi-Fi use cases. And what you see here is a picture of Link, New York. New York is providing broadband access in a way that's just, they're the market leader here, the city leader in a number of ways. But one specific project, all of those blue dots are old payphones, and they're going to change those payphones out with blisteringly fast Wi-Fi. I had the opportunity to go to a beta-tested Link terminal, and it was like 200 megabits per second, far faster than I get at home. And so what I wanted to look at was, well, what would happen if an LTE eNode B, a typical deployment, were interfering with that Link terminal? What would that mean for coverage? And so here, if you look, this is outdoor, and it's providing a big range of coverage. And about 90% of the links are at signals that are below minus 72. So the vast majority of geographic area. It doesn't mean that that's the vast majority of links, but it's the vast majority of geographic area. And then if you'd click once or twice, again. So what happens here is if LTEU and LAA aren't modified, it would reduce your coverage area to about 10% of the original coverage area in terms of broadband access. So if you're New York City and you're investing in continuous Wi-Fi and you're using Hotspot 2.0, so you have roaming, you might not like that effect. Well, now there's going to be some holes in your coverage area. Next slide. Sorry, again. I warned you it was going to be a little bit painful. So then if you look at your typical home, and we modeled this to look like an apartment, so something that's maybe 600-700 square meters, 1,500 square feet, and typically you'd have one Wi-Fi access point. And this is basically a heat map, and as you go through walls, you'll have some signal loss. As you go through floors, you'll have some signal loss. But typically, one router is sufficient to give you whole home broadband coverage. And that's even for the Internet of Things, like smoke alarms and other things that aren't typically in the center of the room. It's generally sufficient, okay? And so if you'd click several times here again, what happens one more time, once you turn on LTEU and you have interference into that Wi-Fi AP and into the client devices, your consumer devices, several rooms could go dark. If you're a consumer and you're not educated in networking, you're probably not going to know what to do if no longer able to function with your portable device or your TV or your wireless setup. Next and final slide. Then finally, there are lots of cases where you have a Wi-Fi AP and you're trying to cover outdoor areas, whether it's a patio, a parking lot, and it's the same sort of deal here. You're going to have some loss, some signal loss before you get outside because of your windows, because of your walls. You turn on LTEU or LAA at your lamppost access, and once again, you'd have shrinking coverage where you're down to about 10%. So if you just go ahead and click through, a spoiler alert there. Once again, the same thing. So Broadcom has been a very strong and staunch proponent for getting the coexistence right before deployment. Because these spectrum commons must be managed. Otherwise, you're going to have an increasing noise floor. The airwaves are going to be less efficient, and we're not going to be able to provide the sort of broadband access that we all want to provide.
So just, and I want to get to the rest of the panels, but just a quick clarification. So is this based on testing you've done, or is this just pretty slides?
No, so interest of full disclosure, I work for Team Wi-Fi, okay? So, but Broadcom does have a small cell department. And we introduced a small cell in Dallas, I think it was back in, I want to say November. And we talked a little bit about our LAA product. And now Broadcom, because we're a large provider in Wi-Fi, have gone to great extremes to make it friendlier to Wi-Fi. But what we're contending is that the baseline, that shouldn't be the ending point. The baseline should be protecting deployed Wi-Fi devices. So we've done testing. We've done manual duty cycling. We wanted to understand what the impact would be. We wanted to understand what the impact would be on typical signals. So yeah, this is based on simulations and tests.
Okay. So what I want to do next is just go to Shakran. What I'd like you to do is if you could introduce WBA to this audience. And then talk about some of the